Hello there guys, welcome back to another live stream. My name's Mike, aka Decimal Punked, and we are in the Unreal Engine 5.5.4. This is my solo uni project. It's called C.E.S.A.R, Celestial Engineers Search and Rescue. The objective, search the level for all the lootables and hopefully find some creatures. Escort them back to the centre of the map. Repeat 4 times. Level complete. Last night I did a very long stream, 7.5 hours, and we implemented the retreat logic for C.E.S.A.R up here. What did I just do there? For C.E.S.A.R and Gelatino. So Gelatino is here. I don't know why all the tabs are all over the place. Let me just sort that out quickly. So I have done some work off stream because where I was where I was working on Gelatino, he's quite complicated. He's the only creature that's got this complicated mechanic. C.E.S.A.R will basically just find a spot, move to it, panic, find a new spot and repeat that on loop. However, Gelatino, he basically morphs into the shape of a nearby container. And I'll just show you the code for that. So, this is the behaviour tree for Gelatino. And this is the behaviour tree. This is the behaviour tree for C.E.S.A.R. You can see the size there, guys. That is the retreat logic. C.E.S.A.R, and this is Gelatino. So I'll just talk you through the logic and then I'll show you it in action. Like I say, last night it was... I still don't know why it's been a bugger, but I've done this off stream. I've reworked the code and it works a lot better. So basically, this logic here is essentially the same as the other behaviour tree task. But what we're doing is once we're setting the random reachable point as a variable called RRP, stands for random reachable point, and then we're doing a do once, where we find all of the actors in the game with the tag lootable, and they're only the objects I've given a tag, such as the crate and the barrel. I didn't go for the locker because the locker's pivot point is central to it, so if that was to be set, the mesh would basically be on the floor, like half in the floor, half below the floor. So then within that, we're doing a for each loop, and essentially what we're doing is we're getting the distance from the lootable to the creature, and then the same here, we're getting the distance from the target location to the creature, and then we're basically saying, okay, if the lootable is less than the length of the target location to the creature, we're going to add them to an array, and the array is called nearby actors. And then once that loop's been completed, we're getting our creature, we're turning off the skeletal mesh, and we're setting the static mesh component on. And then here we're just checking the length of the array. If it's 0, nothing's in there, we go straight to setting the blackboard vector with the retreat location. We clear the array, so next time this event is triggered, it won't have any data from before. And then we're resetting the do once function, and then we execute. And then if the array does have something in there, then we're basically choosing a random thing there. Why have I done that? Hold on. I don't know why I did that. There we go. So yeah, we choose a random item from the array. We name that as the chosen prop. And then we get the static mesh component from that actor. We target the static mesh and we set the static mesh of the creature to that. So it's fairly straightforward. There's quite a lot going on there though. But I'm going to show you this in action, guys. And what I've done temporarily is I've bypassed the randomization of a creature being spawned. Or else I'm having to repeat the simulation until I get that creature. So I've temporarily bypassed the normal code and just guaranteed we're getting the creature that we're developing at the moment. So I'll show you it in action. So we get our creature. I know there's a tiny little bug. Well, it's not really a bug, it's something that needs sorting out with the radar. So we go out of the leash distance and he's picked a prop. If I hide where he can't see me, we can actually watch his behaviour. And he's found me. I'm just going to hide here and watch him. So you can see the available props in this room. It's within a 2000 radius. So he's picking the crates. And then there's one crate that is open, so the static mesh will switch between that. So I'm going to create like a little visual effects or something, just a little puff of smoke or something, so when he transforms it's like a it's really funny watching him move around. It's so brilliant. And I'm going to show you this. See, no errors on the code there. I'm going to show you this up here in the science lab. So you can see that he will pick a barrel because it's within the 2000 radius. Right, so I just need to hide from him. If he sees me, he comes back. Right, so he's in the crate. It's really cool. Look, see, he's turned into a barrel. It's brilliant. I'm so happy with it. I spent 2 hours last night trying to figure out what the problem was. Because there was the code, for those of you that were with me last night, you would have seen the code, and it was struggling to basically read the target location of the actor. I still don't understand why it's been a bastard, but I've got it working. I'm really happy with it. I think it looks so good. So now he should pick a crate because he should be out of the range of the barrels. There we go. So that is Gelatino, guys. I'm so happy. Right, so we've got 2 more creatures to do the retreat logic for. And then that is literally the follow the player retreat logic. And then we need to have the logic for we need to have the retreat logic for, sorry, apologies. Follow the player, retreat logic, and then if they're captured by the robot, they need to basically follow the robot. move to the location and then destroy the creature gets destroyed in the process. So that's what we're going to do. So we've done Gakanda and Gelatino. So what I'm going to do is, if we go to Gelatino's behaviour tree, I'm actually going to close Gelatino because he's all done. Yeah, so this is the logic. So Gelatino's, if I just show you Gelatino's behaviour tree, you see the difference here. We find location, move to it, and wait. Whereas Gakanda has a play animation, find location, move to it, and then the idle. So Gelatino is, because of his morphing ability, he won't be playing an animation. So that's why we are going to do Gakanda's. And also, bear with me, let me just look at my documentation. We need to set the movement speed. So basically, Gakanda and Gelatino, the ones we've already done, they move at the same speed. Their movement speed is the same speed. Okay, so follow speed. Let me just bring up the robot. If we open up Gakanda, follow. If I just go, sorry, I just want to make sure I'm not missing anything. Okay. Okay, got ya. Right, so we're gonna change this because if I do, I think I'm gonna do Bear Coon next. We'll spawn Bear Coon. because we're going to be programming him next. Okay. So, like I say, that code bypass guarantees we're getting the creature we want. This is important for developing, so we don't have to go through a 1 in 4 chance of getting the creature we need. Let me just look at the code here. Okay. Right, so we're doing Bear Coon, aren't we? So open up the blueprint, open up the controller. And the behaviour tree. So what we need to do is we need to mirror we need to mirror this. Okay. Okay, so what we need to do is we need to do this top section. So the way there's different parts to this. So we've already got 2 creatures with this logic implemented. So to replicate it on the other creature, there's a few steps. So we start by this top bit. So you can see up the top here, we don't have a begin play. So we're gonna get this. And that's gonna be HUD ref. And then do this, player ref. Okay, so begin of play. When the creature comes into play, or the controller, we're creating we're creating a reference to the HUD and the player. Now with that done, sorry, we can come down here we've already got the portal triggered. Let me just tidy up these bits of code so they're all in line. What's going on there then? Okay. Right, so references, process, perception, portal triggered. So portal triggered. Now we're going to do this. So we need a key, a Boolean key under here for lost player. So copy that, go to Bear Coon's Blackboard, new key, lost player, save. And then we'll create a custom event called lost player. Okay. And then we're going to set a ball. And then we promote it to a variable called lost player. And you can see lost player variable name, and the default value needs to be lost player. Okay, so lost player, lost player. So we're setting that Boolean as true. And then we're going to be doing the found player. Custom event. And the found player, we're going to do the same, but we're going to be setting it off. Check the variables, they're correct. So lost player on, found player, lost player goes off. And then we're gonna get the HUD ref, widget ref. And then we're gonna target radar visible. Oh. And then we're going to do an if. So HUD ref, widget ref, target the radar. If the radar is false, going to get the player ref. And set is escorting. To true. And then we trigger the show radar. Compile, save. So if we just zoom out there, they should look identical. And then there was one more little bit to do here, and that all we have to do is drop in the found player custom event. So when they sense the player, we're triggering all that code. So after the true on the perception, found player. Oosh. Okay. That should be it for that one. And then if we go to the blueprint, we're adding a variable here. By default, that's off. So if has lost player is true, hold on, now I'm getting confused. Where is the bit where I was on the player character? Ah, yeah, here it is. Yeah. I was wondering, I couldn't remember where it happened. So now we're gonna get the Bear-Coon controller. And trigger the lost player. Okay. So if we've lost a player, the moment we go into that, we turn it straight off so it doesn't trigger it loads of times. We get the Bear-Coon controller and target lost player. So if I zoom out there, that should be the exact same. Perfect. So now we go on here and we get the tag of the creature. And then we get Bear-Coon, BP Bear-Coon. Okay. So Bear-Coon, if it's Bear-Coon, get that, set that. That should be all that's needed in the player blueprint for that creature. So now that we've got that logic in there for the creature losing the player, if we now go to behavior tree, let me just check the blackboard keys. Okay. So if we go to the behavior tree for both of those, you can see on Gekanda now because Gekanda sorry, one sec, guys. So we need to create the find random location, which is basically this little bit of code, but then one second. What is going on there? Gelatino. Find random location. It's called patrol radius there. Patrol radius. Yeah. Sorry, I think I was losing my marbles then, guys. Sorry. Sorry, there are, as you can see, I have so many tabs open. And there's lots going on with gateway. I refer to it as gateway. Like you're putting in these gateway blocks, only allowing certain parts of the behaviour tree to happen based on certain conditions being set with the keys in the code, the controllers, and the blueprints. So there's a lot going on. Right, so. So we need to have a random location, and where we've got this follow player, if I just show you that, all that's doing is updating the speed. So what I'm going to do is I'm going to create two behaviour tree tasks. We're going to have one for retreat speed, because Bear-Coon, if we go to the behaviour tree, you can see here his follow speed. All of the creatures follow the player at the same speed of 150 units. But Bear-Coon's meant to like run quite fast. He's a bit of a cross between a hedgehog, a rat, and a bear. As a little bit of a homage to Sonic. I thought it'd be funny just to make him move quite fast. So that's what we're gonna do. So we can get rid of that wait node. And on the logic for lose player, the first thing we do is play the run animation. So that's Gekanda run. If I just quickly check Gekanda's run animation, Gekanda run 1.2. He's set to 1.2. 1.2. 1.2, 1.2, 1.2. So we're going to set this to 1.2 as well. Now, because I'm essentially doubling the movement speed. If you think about it, Gekanda and Gekanda and Gelatino move at 150 units. So if Bear-Coon is going to move at 300 units, that animation rate scale is going to need to go up as well. So if I did it at 1.4, I think that's going to be better. One thing I also need to do is just bring in Bear-Coon's animation for look. So he's got a look animation for when he idles after he's reached his spot. He's such an ugly creature, bless him. Okay. So, first thing to do is to play animation, and it's going to be looping, non-blocking, and it's going to be the run. So, play animation, looping, blocking, and this is, to run. Okay. What we'll also do is, you see we've got this decorator. We're going to add the has lost player decorator. And if we click on that, is set lost player. So if we just check that, result change both, result change both, is set lost player. Okay. So that's the first thing. Now what we need to do is I'm just going to open up the robots behavior tree. Technically, I could do that within the same. I'll do that in the same same thing. So where we've got the find random patrol, we just need to plug in the speed as well. Oh my god, I have so many tabs open. Right, Bear Coon. So we've got that part done. What we'll do is we'll fix the rest of this, because as you can see over here it's slightly different. I've put in 3 conditions, decorators, for the follow player. So we need to make this for BTT Bear Coon find random location. So if I just bring that down here, go blueprint class, you want to type in BTT and select the top one, which is BTT task blueprint base. We paste, as I copied the file name from the other one, and we're going to take out Gelatino's name and replace that with Bear Coon. And we'll put that there. Okay, so we have the behavior. Oh my god, they're so small I can't even see them. Okay, so behavior tree task. I don't need the follow player one open. Actually, we'll leave that one there. So now what we're going to be doing is just doing this, guys. Quite simple. Now we'll check the key, retreat location. Should have that already. Retreat location. There we go. Okay, so going back to this one, the find random location. We're going to copy this. We're going to go to the behavior tree task for Bear Coon find random location. Boom. And then we're going to get actor's location, which is the controlled pawn. And then we're going to get the random reachable point in radius. So basically, on Gakanda, the retreat location is 850 units. Gelatino, if I just double check, I think Gelatino is set to 1200, so it's almost, it's an extra, it's the third extra of the other creature. And the reason why I set him a little bit higher is because I want him to I might actually change that to 1600. Because the idea is he's a prop. He's morphed into a prop. Actually, I'm going to do 1500. And if I just go into the code for Gelatino. Not that one. 1200, it's already been set there, so it's 1200. We're in Gelatino. So 1500 patrol radius, 1500. There we go. So 1500 for Gelatino. And then 1500 there. Cool. Okay, sorry about that, guys. Okay. So I'm going to do the patrol radius. I might set it at 1000. So basically, Gelatino is 1500 because he moves into the shape of a prop and then he moves around, so that gives him a bigger area to move and hopefully land near a prop, so he blends in with the environment. And then Bearcoon I'll probably set at 1000. So what we're going to do is we're going to promote that to a variable. We'll give it a default value of 1000. We'll set it to instance editable. So I'm going to copy the patrol radius, paste that, rename it, compile, save, and then we're going to set the value to 1000, and then instance editable, so that within the behavior tree we'll be able to adjust that if we wanted to. We don't need to set a class, so now we need an if coming off of that. Okay, so if that is true, I'm just going to have a sip of the coffee, guys. Coffee is my game dev rocket fuel. I love it. And it's literally that, guys. It's that simple. Set the blackboard value as vector. So I'm going to copy that. We're going to go over here. If that's true, do that. And the value is going to be from that. Plonk. And then we get the retreat location, instance editable. There is no default value, so we're going to copy that, promote that to a variable, instance editable. So retreat location, instance editable, none, compile, save, and then we copy it, and then we get the actor's location. And then this one. So that is essentially Bearcoon's logic for finding a spot and setting the key of the retreat location. What behaviour trees are quite complicated, but if you break it down, they do feel like just like a blueprint in the way they function. You know, you have all the keys, you got the variables, you can set things and have certain conditions for certain parts of the logic to work. Once you get your head around that, it's not that scary. I don't know what everyone's thoughts is on behaviour trees, but that's my advice. Just break it down and think of it as a vertical kind of blueprint that's prioritised from left to right. It's one important thing with the behaviour trees, guys. Everything flows from left to right, so it will go far left and then work right. So in essence, the flow of a behaviour tree is the same direction as a blueprint, but the layout of the nodes is vertical. That's a good way of describing it. Okay, so let's go back to here. So in this blueprint task, behaviour tree task, we've got this. We've got the patrol radius that is we're able to kind of set. But what we want to do is, in addition to this, we want to set the movement speed. So in the follow player, we're basically going to do this. We're going to cast to Bearcoon and update the walk speed. Okay. So cast to BP Bearcoon. And then we're going to update the walk speed. Ugh. And then we're going to promote that to a variable, and we're going to call it retreat speed. Make it instance editable, so we'll be able to access that. And the default speed is going to be 300. And I'm going to put that there. Okay. And that's all we need to do there. So I can close that one. Oh, you bugger. Retreat speed, instance editable, control radius. Okay, I'm just going to move that down a tad. Move that back one. Compile and save. So now we've got that behaviour tree task complete. So now what I should be able to do is call the Bear-Coon find random location. Bear-Coon find random location. And there we have it, guys. We have the patrol radius set at 1000, retreat speed set to 300. Okay, so what we need to do is we need to click on that, and the retreat location needs to be set to the retreat location key on the blackboard. Okay, so we're saying pick somewhere within 1000 units of the creature's position, set that as the retreat location, and we're setting the movement speed. So you see down here, if he's following the player it's 150, if he's retreating it's 300, so he's twice as fast. Which means, if you lose this creature, you better move fast. You wait till we get to Octo-Nymph. Octo-Nymph is a flying creature, so I was going to have him fly. So let's go back here. What do we need to do? Now we need to get a move to. I'm just going to rename that as well. Give that a name. So find random location. And then we need a move to. And this is going to be the retreat location. Retreat location. Okay, so once Bear-Coon has done the move to, we're going to have an idle sequence. Okay. And the idle sequence is quite simply play an animation and wait. Now Bear-Coon, looking at my design document, I think Bear-Coon waits for 4 seconds. So basically, Gelatino waits for 5. If I just show you Gelatino's, Gelatino waits for 5. Gekanda waits for 5. Bear-Coon waits for 4. Octo-Nymph waits for 3. So because Octo-Nymph's movement is the fastest and his wait time is the shortest, it means if you don't get to him quick, he's going to pick a new spot and move fast. And what you don't want to happen is the robot catch it. Okay. So, Gekanda, so idle, back to Bear-Coon. So off of the idle, we're going to play the animation for Bear-Coon. Ugh. And the animation, if we click on that, looping, non-blocking. That's Gekanda scared. So Bear-Coon's one is the look animation. So we're going to go into Bear-Coon. And it's the look animation. And then we wait for 4 seconds. Okay. Okay. Right, so now what we need to do is tidy up these bits here. And then we can test it, and it should work perfectly. Okay, so let's come out of here. So what we're going to do is we're going to add all of this. So I'm actually going to move this particular behavior tree to my second monitor, because it's quite, as you can see, it's quite a big screen, so you guys will be able to see what I'm doing. So we're going to move this back to about here, and has line of sight. We're going to add a decorator to this blackboard, and this is going to be not reached portal. Portal reached is not set. And then we're going to add another one, and this is going to be called hasn't lost player. Lost player is not set. And then what we'll be able to do, you can see here, portal reached is not set. It's the same thing. So now we can do abort both, and then we can move this up, move this just there. And there we have it. So just checking both. Just checking it matches up with the other one. So has line of sight is set. Portal reached is not set. Lost player is not set. Right, I believe that is all ready to go. So it goes 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Lovely. So save that. I can close the Gakanda. Actually, we'll leave that up for the moment. So this should work now, guys. I've covered every step. So we're going to go save all. And we know from the spawn manager we're going to get a bear coon, because I've overridden the default logic. And we just test it now. So he should spawn. He'll follow us. And then if we were to lose sight. Oh wow. Holy shit, he's fast. Oh, that's brilliant. Oh, that is so cool. It's so fun putting all the most rewarding thing about game dev is all the work you put into it. All the code, making sure everything's just functioning right, and then seeing the end result of it coming to life. That's the best thing about game dev. Hello, mate. You alright, dude? Let's get you out of here. He's gonna see me. See, that's one thing we need to sort out where I think it's the sense he'll spot you and then the radar will blip on and off. So there's a tiny bit of tweaking to be done just on the logic there. Now, there was one thing that I wanted to do with the creature and that perception range. Holy shit, bro. Oh, it works so well, guys. It works so well. I'm so happy. Let me just show you, right? So, on the controller, on the AI perception, what I wanted to do, I wanted to set the sight. That's what's happening. So basically, when a creature is in retreat mode, I don't want them to be running around and then they'll be able to see you from miles away. I want them to basically have a reduced sight radius, which means when they're in their retreat logic, you have to physically go up to them to reinitialize the follow logic. And I couldn't figure out a way to kind of do this. It was really, really annoying. But I'm really happy, guys. That works perfectly, the logic there for Bear-Coon. So we can close Gekanda. Because the Bear-Coon logic is going to be the exact same for Octo-Nymph, where we're implementing a faster speed on the retreat. So I'm just going to see if there's a way that I can set sight. Like you can see there, set sight radius. Like, I need to query this because I... Ah. Editable. There has to be a way we can... There has to be a way that we can access that data. Well, I just want to be able to set this data. But like, you can't... I don't know how... That's one thing I need to do, because at the moment, if you lose a creature, it will spot you from ages away. Oh, we don't want that. We want the player to be able to I can't see any other options there. This does need to be done. I just don't know. How can we access that information? Like, why? There has to be a way we can access this. Has to be. I'm just going to post about this quickly in a group and just see if someone might have an answer, because I'm genuinely clueless on this. Give me 1 second, guys. Okay, right, I've posted a message asking about that. See if I can get some help. Someone somewhere must know how I can access this data. There has to be a way, an easy way, where we can just... I'm genuinely clueless, guys. But anywho, we have Bear Coon is working. I'll just show you that again. Where are you going, bro? The robot's that way. Thank you for the spam view, Concave. I appreciate that. Okay, there's no bugs with that. So, whilst I'm waiting for a response on my query, what we're going to do is we're going to do the retreat logic. I can actually get rid of the enemy and that one. Free up the workspace. So we're now going to set the spawn to be Octo-Nymph. So whenever we open a container, we're going to get the Octonaut. He's so funny. Okay. Right. So what we're going to do first, if I remember, we're going to open up Octo-Nymph. So we need the blueprint. We need the controller. And the behaviour tree. So I think the first thing we do is the begin play. Up here. Set the HUD ref. Set the player ref. Right, so we've... Oh, we also need to do the decals. I forgot about the decals around the space station. Okay, so... Sorry. Oh my god. Okay. Set the references. We've got the portal triggered. So now what we're going to do is we're going to do this. So we need to have the lost player key on Octonym. Okay. So now lost player custom event. And then we'll just check that. Why am I getting a compile on Bear? I've not made any changes. I'm literally clicking. So lost player, lost player. Okay, so the lost player custom event says the lost player key is true. And then we're going to have a found player. Where we get this. And we say it's false. Then we're going to get the HUD ref and the widget ref. And then get radar visible. and then show radar. Okay. So I don't know why it keeps asking me to. I'm not changing anything in this. Why do I keep having to save this controller? Makes no sense. What's going on? One last bit. After the true, we need to do the found player. GG. So that is the controller done. So now on the blueprint, we do this bit here. So we're going to copy that boolean. Octoninth controller. And we target lost player. Okay. Right, so I think we're done in there as well. So now we go to the first person. Copy the tag. go. So that handles so we've done the blueprint for the creature, we've done the controller, so now we need to mirror this basically over here. So we're going to play animation. Oh, we'll just do that decorator first. And we're going to play animation. And then all we need to do is basically create the same code here. I'll probably have the same radius at 1,000. Actually, I might go... Ooh, I'm going to go 1,200. So we need to create this task. So it's BTT and then select BTT task blueprint base. And then we're going to name this Octo Nymph. Open it up. I'm going to just save all as well. Right. So we're going to be mirroring the code here. So we're going to copy this. And then we're going to cast to Octo Nymph. Oh my god, am I going to have him move really fast? I think I'm going to go 425 on the retreat speed. So I'm going to go promote that. Okay. There you go, same code. So now that we've got that done, I believe the last thing is to do the behaviour tree. So what we now do is we'll copy this. It's going to be octonym random location. Ah, yes. I have an animation to bring in. And his wait is, I think, 3 seconds. Okay, what I'm going to do, I'm going to bring this out to my second monitor so I can make sure all of this marries up. Okay, animation, find a random location, move. Okay. So now I'm going to sort out the middle section. Eight, 9, 10, 11, 12, 13. Yeah. Right, I think we're ready to test this. Let's give it a go. It's like Superman. think I need a different animation for when he's idle. Okay. Very happy with that. As you can see, no errors. The logic works. When you lose him, he flies off much faster rate. Okay, let's sort out a animation. So we have done the retreat logic for the creatures. The last bit of logic for the creatures then is when they're captured by the AI. And then we've got, if I go to my blueprint for the portal, I mean, it should be fairly straightforward to do the logic for when they're captured by a robot, because it all it's the exact same for all of them. They'll go in a bubble. Their speed will be the same as the robots, and then the robot takes them to a container and puts them in it. So very happy with that though. I think what I could do it's going to be tricky actually, because essentially it's two MPs, two behaviour trees kind of communicating between each other. So it's going to be like if a boolean on the creature is set to such and such. I think I know how I can do this. But I think what would be good is if I took a break. If we sort an animation, a suitable animation for Octonymph, because the one I've found, it's not quite right when he's come to a stop after retreating. So we're going to source the animation, switch it out, play test, check it's appropriate. Then I'm going to take a break, and then I'll come back and I will program the captured logic for the creatures. And like I say, it's the entire same for all four. And then all that's left is to code the logic for the robot. So run mixer now. Let's see if there's... This is with the one we've got for where they are... Oh wait, hold on. Ah, we've already got that one there. That is the same, isn't it? Or is it? I am so confused right now. Yeah, that is the one we've got. Gotta love the YouTube adverts, guys. Give me 1 second. We need an appropriate animation for when he's idle. It's tricky though, because he's a floating... He's a floating... And this one is too arched over. Actually... Perfect. Let's try that. That is a stretch. This should be better. There we go. And that's 90 seconds on the dot as well, guys. So let's give that a go. So instead of the one I had before was kind of like more if he came into collision with something. He found me. Hello, mate. Oh no, he's stuck. Does go quite a distance sometimes. Oh, it didn't sense us then. Okay, so that little bug fix with the radar blipping up and off. I mean, I'm just thinking actually, there might be a much more efficient way of having that, because at the moment, the radar is hidden. The only time the radar is hidden and shown is when a creature is following the player or not. So, essentially, if we go to a behaviour tree, if I was to have, I could just have a task called show radar, hide radar. Two simple tasks, and then we would basically have it plugged into here. I think that would actually bypass the radar blip problem, because the way it works at the moment is it's only ever shown on this part of the logic. So if we were to remove it from here, create a loop behavior tree task, I think that's going to be a much more effective way, and then plugging it into the 4 parts, because that's the only time where it should be shown. So I'm going to try that quickly. We have done, like I say guys, we have done all of the retreat logic for each creature, and they're all slightly different, especially Gelatino. So the last bit to do is the creature being captured logic. Now that's going to be easy enough to do. So I'm just going to create a behavior tree task for show radar, hide radar. So I'm going to close. And then what we can do is on those controllers, yeah. Right, let me close all of these. Okay. I think this is going to be much more efficient, and it's going to fix that issue where a creature, because at the moment when we have the radar blipping up and off, blipping on and off, it's kind of where the creature sights us. It then kind of in a split second acknowledges it's sighted the player, but then it does its own thing. So I think that's something to do with experimenting with the perception variables and settings. But I genuinely think this is going to be a much more efficient route. So we're going to get this and do that. It should be that simple. It should be that simple. So show radar, hide radar, compile save, compile save. And then okay, so where we've got the radar being shown, I'm going to temporarily unplug that. And then I'm going to need to go into the creatures. Show radar on begin play. We can leave that there. I think it's just in here. So I've unplugged the radar. So if I go into all the controllers and just unplug the radar. And now, if we open up all the behavior trees, I have a good feeling this is going to work. I have a very good feeling that this is going to be a much more efficient way of showing the radar. Welcome to the stream. Hey Siege, welcome to the stream, dude. How have you been, mate? The game is coming along really, really well. I wouldn't say it's too complicated, but dude, I've almost finished the whole logic for the creatures. What I'm doing is I'm just optimizing the way that the radar UI widget is displayed on screen, because I was having this issue where the creatures would very, for a split second, spot the player, toggle the radar on, and then toggle it off. So I've unplugged the code in the blueprints where I'm specifically handling the radar, and I'm plugging it into the behavior tree itself. So this should be a much more efficient way. But but welcome to the stream. After I've done this and play tested it, I'm going to stop for some food, and then I'm going to come back and implement the logic for when a creature is captured by the robot. And then the last thing to do, logic-wise, is the robot's behaviour tree. I've got 2 different robots. We've already got the chase player and escort, so they just need the logic doing for capturing a creature, and what else? Capturing a creature and damaging the player. And then there was another one I wanted to do where the robot investigates a sound. So if the player is rummaging through an item and the robot hears it, it will go to investigate. So don't think that's going to take too long because we only have 2 robots. So anyway, let me just quickly implement the rest of this, and then you'll see what I've done, dude. I don't know when you were last on stream, but I've done quite a lot to this. Quite a lot. What time zone are you, dude? I can't remember if you're from the UK as well. I've got so many viewers that tune in from all over the world, so I can't keep track of who's from where and the time zones. 8, 9, 10. Right, okay, let's see if this works. So I'm going to save all. And like I say, I've unplugged the radar there. What's this? This is the portal. So I'm letting the portal hide the radar. And then we've unplugged the radar in all 4 controllers. So let's give this a play. I'm going to turn off... Oh, you're US. Nice, dude. Okay. Right, so when we get a creature... oh, actually, now that we've got the 4 logic in, what I can do is I can just plug back in... Because with Octonymph, this... Because what was happening, there's 4 creatures. So when you get a creature... If I'm developing a certain creature, I want to be able to just have that creature. So I put in a temporary bypass to the logic there. So I'm going to unplug that, but I'm going to leave that there, guys, because when we implement the retreat logic, the captured logic, we might need that again. But it should be okay. So I'm going to plug this back in. Literally just like that. Okay. And now I'll play test the whole game. You'll see all 4 creatures. Okay, so I've got Bear Coon. He runs really fast. Oh, interesting. The radar just popped up. Ooh. Why is it popping up then? So if I stay hidden... Oh, I see. It's triggering it multiple times. That's why it's It's not ever going into there. I see. I see. Okay. It's, yeah, okay. Okay. Where's he gone? Where's he gone? Oh, he's over there. You alright, dude? I love it! I love watching him run. Oh my god. Right, let's just save the creatures. I'll show you the other three. So if you lose... If the proximity radar goes above, the creature's retreat logic kicks in. Let's go get another one. Here we go. Right, Gelatino's funny. Oh! Where are you, buddy? He's gone invisible. Oh no. Where is he? Okay. Okay, I think what I need to do is increase the radius then on him. Interesting. Okay. So, I know what I need to do with that one. So we're going to fix the radar. And then fix Gelatino. I know what's causing the problem there. He wasn't invisible as such. It was... He couldn't find... Right, this guy flies around. So if you lose this one, he moves really fast. He's the hardest one, I'd say. Game complete. Boom. Okay. Oh, who was that? Gelatino. Okay. He's got a 1500 patrol radius. How did he not find a prop? What's meant to happen is he's meant to find a prop within that distance. Oh, I know. I know. Right, so what we need to do in the hide radar, we kind of need to check the position. So I can have some code in there to say because what was happening on all of the behaviour trees, the radar is getting shown and hidden, but the problem is if this is repeated a second time, we only need that to happen once. If set set, task search will be discarded when this task is selected to execute but is already running. So, we might be able to handle that with a decorator. I just need to go into the gelatino. Okay, so the patrol radius is 1500. So it's picking a random spot within 1500 units. And then this is the problem. If it's not finding any actors, if the creature, where my cursor is, if the creature was this box and it picked a tiny location right near it, the likelihood is it won't find any actors, any containers to put into the array, which is why it turns invisible. So that's probably what happened there. It bypassed all of that and just went into there. So this isn't a problem. I guess what we could do, in the instance that the array is empty, this is going to be a good bug fix. Yeah, okay, what we'll do, we'll put in a bug fix here for gelatino. So we're going to get 2 of these. The static mesh will be barrel closed or crate closed, and it's going to be random int and range 0 to 1, and then we'll do a switch on int. So basically what I'm doing here, this is going to cover instances where if there's no props, if there is no props from this calculation, then we're basically saying, okay, make him a barrel or a crate. That's what we're doing there. Oh. Oh, I haven't set the target. Right, so let's test that. So Gelatino should now have a fix. So in the instance that the array is empty, we're ensuring that he's going to have a model to morph into. Okay, so we're going to test this and then we're going to put in a bug fix for the radar. Let's go, baby! Let's go! This is a good test. There we go, see? There obviously wasn't a mesh in this area. All of this area has crates. So the fact he's turned into a barrel, I know that means that the array is empty. And what we can quickly do as well is we can do a print string. Append. Just temporarily so we can actually see that. Oh, I'm so proud of this game. I've really enjoyed making this. There's a lot of stuff I've done in this that I've not done in other projects, so it's really cool to see. Array contains 0. There we go. Did you see that, guys? Array contains 0. So he's staying as the barrel because he's failing to find an actor to morph into. So if his location he picks is near one of those objects, then he should morph into that. Very interesting to see. It's watching him walk around as a barrel. That is what his purpose. He is meant to do that, by the way, guys. There we go. He's found a suitable actor there. We didn't get the developer string pop up. So he picked a location. There were actors from within a certain point of that location. So if he comes back towards my way, I know there's only 4 crates in this room. So if he picked a spot over there, he's going to turn to the barrel. Or the crate. The array contains 0 that time. So it's doing the dice roll there. And it's either choosing the crate or the barrel. So it's a 50% chance. So if you get 0 again, it could be the barrel. Right, he's found a spot with eligible actors to morph into. And we know it's the crates. There we go. So he's picked a location not near any illegible actors, interestingly. I love the reflections on everything as everything's moving. Right, if he picks a location now, this might be the barrel. No. There we go. So he's picked something that... Well, thank you for the spam view, alcoholic. Off he goes. So that worked really well. So we know that's working. So that code is perfect. Plug that back in. So that's a bug fix for Gelatino. Let me just check my list. Looting stops working. Okay. Right, so that is the bug fix done for Gelatino going invisible if there isn't any actors in the array. This part here will determine the random point selected. It will get actors within that location distance and add them to an array. So in the event that the array is empty, we need to manually set the static match. So that handles that case. So that is a bug fix. Right. So what we need to do then is, if I just show you, in the event that we get a creature, we lose them and their retreat logic kicks in. If you watch what happens, I'm hidden out of sight. That radar's going to hide. See that? It's going to keep coming up. Every time it finds a new spot. That's because it's playing the animation over and over again. But we only want that to happen Oh! Well, that's interesting. So the radar... Spazzing out. We only want that to happen once. And you can just see on the bottom right there, guys, the flickering of the radar. At the bottom right, there's a very thin blue line. So, I think it is more efficient having this in here. But I guess a safety way of doing this. Okay, if you think, let's think about this logically, right? We show the radar, we hide the radar. If the radar is already hidden, we don't want to play that animation again. Same for the show. If the radar is already shown, we don't want to show it, which should stop the animation from playing multiple times. So if I was to go into here and what we want to, sorry, beatbox nonsense. If I open up my HUD, save all, go to the graph, and we want to get these 3 variables, and we want to get the alignment. So basically, if the alignment is 0 and 1, that means it's hidden. Okay. If the alignment is 1, 1, then, like if we did 1, okay, so what I'm going to do is I'm going to go, what do we need to target? The variables is those 3, radar frame, bar and overlay. So if we go in here, get radar, hold on, there's 3. Bar, so radar frame, and then get alignment. Oh. Canvas panel slot. There we go. There we go. So if we bring that one up, what we're doing here is we are going to be checking we're going to be checking that the alignment is the same for all 3. And it's the, is it the X we wanted? Yeah, so if X equals 0, it's already hidden. So we're in the hide radar, so we're going to do an if. If that equals 0, X is 0, it's already hidden. So if that's true, so if that is true, nothing. But if it's false, so basically we're saying if those canvas objects, if their alignment is 0, that means it's already hidden. So we do not want to trigger the hide radar if it's already hidden. So we can just play test this and just check it. Welcome to the stream, guys. So now, if we lose a creature and we don't engage the sight perception, if I go over here and just hide out of sight, watch the bottom right, that shouldn't come up. Okay, I know that he's going to be moving around. Gelatina has a 5-second delay between finding a new spot. He's over there. Why is he not moving? Why have you stopped, dude? Why did he stop moving? Oh, it's because of... Numpty. It's because off of the true... Oh my god. Right, so in the event that this is true and it's hidden, because we're not finishing the task, it's not updating on here. So it's not going along to the next bit of code. What a numpty! Humpty Numpty. There we go. Silly Billy. I do apologise, guys. The night is late. The hour is late, as they say. Welcome to the stream, guys. Right. So Bear Coon's over there. We're just going to hide out of sight. Watching the bottom right there. There's no flickering of the radar. Before there was, where it was spamming the behaviour tree task. So there we go. Now, it's probably going to get hidden now. There we go. Can you see at the bottom right, it's spamming out? There's a blue line on the bottom right. And if I show you the behaviour tree for Bear Coon, you'll see what's happening is triggering show radar over and over again, because it's at the player's location. So we need to do the same fix that we just did, but for the show radar behavior tree task. Okay, nice and easy, guys. So basically, we're just going to copy these. AI show radar. Okay, so if I'm just going to actually bring this one onto my other window, my other monitor. So basically we're going to move this all the way over here. And I should be able to just copy this code. Oh, that's good. And remember the show radar. So why did I close that widget? Right, so by default the radar is hidden. So if alignment X equals 1, it's visible. Okay, so the opposite now, we're going to say if the radar is 1 on the X alignment, then if that's true, it means the radar's already shown, so we do not want to show it again. But if that's false, we do want to show it. And then what we want to do is bring that in line with that. If we bring that down, we want to have the true going in there. So welcome to the stream, guys. Right, so now if we were to find a creature and just stand still, that radar should stay and it shouldn't glitch out like it was doing. So we're going to save all. Always save your work, guys. Oh, hold on. I'm just going to bring that back up there. So we just need to get a creature. There we go. And then if we lose this one, there we go. Why have you stopped moving, dude? Why did he stop moving then? This is quite an interesting scenario. Why is he not moving? Okay. I think it's safe to say I've fixed the bug with the radar blipping on and off then. We just need to sort out the perception because there's a slight iffiness to the perception of the creature losing the player. It's like it blips on and off. I don't know why Octonymph lost aggro though. I call it aggro, it's just following the player. Not quite sure with that one. Oh, that's perfect. He just blends in with the other props. Love it. I love it so much. Oh, I'm so happy. Okay. So the radar blip, I would say, is fixed. So that was lose creature, spots the player, blips the radar, continues lose logic. So I can turn that off, as in the bug fix list. Lose creature, spots player, blips radar, continues lose logic. Okay, so we fixed that because the only way the radar is going to get shown is on the condition. Before it does that, it checks the alignment to determine, is the radar already hidden? So we can close that, and we can close that. We can close that one. Was there anything else? Oh, I guess what we could do actually, we can close these behaviour trees. And the sections where I've got the radar, I can now remove that because I've fixed that. So get rid of that. Just check the code. So got the widget reference there. So we can compile and save that and close Octonymph's controller. Do the same for Gelatinio. So the show radar can be deleted. As can that can go there. So check the radar visible. Right, so we're just checking that the radar function has been removed. So when BP portal destroys the creature, we hide the radar. That's good. We'll leave that in there for playtesting. We can give this a comment box. Right, so I just need to describe what's going on here. So calculates the distance from the creature to the player, and then sets the progress bar at that value. Okay, calculates distance between creature and player, updates radar. Updates radar progress bar to reflect distance. If radar limit is reached, update creature's logic that they have lost the player. Very simple. So that code, I think we're going to put it down here actually. Nice. Okay. Right, guys. Right. Amazing progress. 3 hours 17 of stream. Call it 3 hours 15 because I always do an introduction. I am going to stop to have some food, have a little break, and then I will be back to program the behavior tree logic for the event that a creature is captured by a robot. That will involve it's going to be quite simple, and it's going to be a copy and pasta job because all 3 creatures will follow the same logic. They're going to have a spherical bubble around them. We're going to raise them up so it looks like they're floating, and they basically will follow. They'll follow the robot's position, and they just follow the robot basically. Literally captured, follow robot, move to location, and then they get destroyed. So the movement speed of the creatures needs to match the robot, and then when the robot gets to destination, we'll set the robot to destroy the creature. That's going to be very simple logic, and I will then make a start on the extra logic for the robot. Now we have 2 robots. We've got the tall humanoid form robot, and then we've got a different one. So I'm going to have a break, and then I will be back to program that. If you enjoyed your stream, guys, feel free to follow on Twitch if you want to stay up to date. And if you want to see any previous streams I've done, feel free to check out my YouTube below. I've got playlists for Unreal, Unity and Blender. Thanks for watching, guys. Stay safe, and I will see you in the next stream.